Hi there, this is Laurence KL7L, and this is another part in the construction of our low frequency loop antennas here up in Alaska. And we got as far as testing the loop this morning. It's Sunday, and this is a 10-foot diameter loop, and it consists of 25 turns of 20 gauge stranded wire on a 10-foot diameter octo loop. And you can see here the way that we restrained the wires. The 1/4 inch spacing between the wires, and inside here is put through this another piece of wood is the coupling wire, and that's connected just as a single loop right around the antenna. And it's connected, the red basically comes in either side there, and it connects directly as one turn to the SO239 here. And the turns themselves, the major part of the loop, come into this box here, and we can select the number of turns by this switch here. And with all the turns connected, that's 25 of them, it works out at about 4.83 millihenry, and then I can sort of change the tappings here using this. Looks messy, but this is actually liquid tape to protect the connections, the solder connections. I can switch the impedance or the number of turns just down, and here 1.35 and 0.82 millihenry. This is a variable capacitor here which we resonate the array with, and this little switch at the moment here, that actually switches an additional 1000 picofarads across the variable capacitor. So what we've done today is that inside the protected environment of the garage here, it's about -25 outside, not perfect location, but we mounted this on a table. Again, not perfect because it's metal, above a concrete floor which is reinforced. Again, not perfect for testing purposes, but we do have a great noise source, which are these lights up here, which are RF balun that produce a lot of RF rubbish between sort of DC and light. And at the moment, what we're doing is we're testing the resonance of the antenna by seeing how far each individual tapping on the loop actually resonates. And at the moment, with 4.85 selected here with the capacitor switched off, the loop can be tuned anywhere from around about 60 kilohertz fully meshed, and then if we change the dial frequency up to 137 kilohertz, another frequency that we're going to be using here, around about here, and we turn up the sensitivity a bit, that's up to about -70 or so. If I turn the capacitor here and look at the meter reading, we get a nice big, whoa, big peak. Let's turn the gain down a bit, and here we go. There's the capacitor being tweaked for maximum, and that's about -70, using the light source up here as an RF generator. Again, not perfect because the thing isn't vertical. It normally would be sitting vertically on this another fiber pole sitting down here. Then the whole lot will be sitting mounted on this 8-foot 4x4, which would be about 4 feet into the ground. I can't do that at the moment because it's the ground is frozen. Anyway, so the main reason for doing this antenna is to add a bit of diversity to the reception. We've got one of these already out there which we use on 74 kilohertz, and I've been listening to Bob in New York at about 5,000 kilometers away, running 1 watt ERP. and we also can obviously switch it down to 137. And if I switch out some of the inductance, I can actually tune the experimental 600 meter band as well. Anyway, so that's it. This is the Octaloop under construction tests. It's got its first coat of marine varnish on the tines, and we'll just let that dry off before we expose it to the environments. This is KL7L in Wasilla, Alaska.